to discuss second chapter of modern physics, that is nuclei. So in this chapter, what are the important topics that are required to face the NEET-based problems as well as the JEE mains-based problems that we discuss. Right. So in this, actually, what we discuss means composite of nuclei, discovery of neutron, nuclear properties, mass defect and binding energy, nuclear forces, radioactivity, law of radioactivity. So all these concepts we will discuss, and along with it, some NEET-based as well as IIT JEE mains related problems also we will discuss. Composition of the nucleus. First of all, let us discuss. So already we know atom. So at the center of the atoms, protons and neutrons will be present, and around that electrons will be revolved in different energy levels. So here we are going to discuss about what means the composition of the nucleus. So just now I told now itself, what consists of the nucleus? Nucleus will be consist of protons as well as if it means neutrons. Protons and neutrons. Then how to identify the given element, or how to mention the given any type of the element? So generally any type of the element will be represented like this: X, Z, A. Where X is the name of the element, Z is the actually called as the atomic number, and A is called as the what means mass number. For example, oxygen 816. So here in the place of the X, I have written O. That tells the oxygen atom. 8 is nothing but what? Atomic number, and 16 is equal to what means mass number. Here atomic number Z is equal to nothing but number of protons present in the what? Nucleus of the given element, or number of electrons in that neutral atom. So this gives the atomic number, and when you come to the what mass number itself, mass number is equal to nothing but A is equal to nothing but sum of the number of protons plus number of neutrons. So with the help of this A, we can find out the number of neutrons that are present in the given nucleus also. For example, number of neutrons is equal to nothing but mass number minus atomic number. So this gives the what? The number of the neutrons present in the given nuclei. Say for example, in this oxygen atom O816, the number of neutrons are is equal to nothing but A minus Z, that is 16 minus 8. That is equal to 8 number of the neutrons. That means in this given nuclei, oxygen 816, clearly we can say that in the nucleus there are 8 number of the protons and 8 number of the neutrons. And like that we can calculate for any given nucleus. For example, uranium 92 to 35. So this is a given atom. So your atomic number is equal to 92. That is nothing but number of the protons. That is nothing but number of electrons also in the neutral uranium atom. And mass number is equal to 235. 235 minus 92 gives the what means the number of the neutrons that are present in the what means given nuclei itself. This is a small description about the what means composition of the nucleus. I think in modern physics, in the first chapter, we already discussed that inside the nucleus, by the Rutherford experiment, the nucleus will be consist of only what means a positive charged protons. positive charged particles, which are nothing but protons itself. At the time, they don't know about the presence of the neutrons in the given nuclei itself. But after conducting this so many experiments, it was observed that along with the proton, some other charged less particles also will be present in the nucleus itself. So that was the experiment given. Actually, this is like this. So when the beryllium 49 actually bombarded with the alpha particles, that is He49. So it was observed that C613 and along with that some energetic particles actually coming from that reaction itself. These energetic radiation, initially it was assumed as what means gamma rays itself. Gamma rays, which are also not actually deflected by any electric field as well as what means magnetic field. And hence they could not understand that whether neutral particles are present in the nucleus or not. But after careful observation, so by this experimental setup, they came to understand that the released what are maybe the rays that are coming out from this nuclear reaction itself, nothing but what means neutrons. That means the equation actually can be written like this: beryllium 914 plus alpha particle. This unstable carbon 6C13 will be actually comes as C612 as well as the what means neutron itself. Here actually, due to the scattering of these alpha particles with the what means beryllium, whatever maybe the radiation is actually coming out, that is passed through the what means paraffin wax, which consists of the what means more number of the protons itself. And as we know, the proton mass is almost equal to the neutron mass itself due to the elastic collision. So what will become what means protons will become out. Now by analyzing the energies of the protons itself, it came to understand that definitely the charged particle, the particles that are coming from this reaction itself are definitely not gamma radiation. Definitely will be some other kind of the what means particles. And later they came to understand that those are nothing but what means neutron itself. This is the discovery of the neutron. And what are the properties of the neutron? That is very simple. It is uncharged particle, and hence it is become very what we say risk to know that whether the neutron charged less particle is present in the nucleus itself. We enable to actually detect that one very easily, and its mass is very nearly equal to the what means mass of the proton itself. In precise, a little bit more than the what means mass of the proton itself, and it has more penetrating power. More penetrating power means it does not have any kind of the charge itself. So it can pass through the what means any type of the material very easily. And less ionizing power. As it is charged less, it cannot be ionized any other atoms or any other molecules and so on like that. And the most important one is it is stable inside the nucleus, but it is unstable outside the nucleus itself. So outside the nucleus, if you take simply the neutron will be disintegrated as proton plus positron, and along with that you will get what means anti-neutron. So it is actually unstable one outside, but whereas it is actually stable inside. So this is about what our neutron itself. So classification of the nuclei. For example, if you look this carbon just now previously we discussed C613 is there as well as C612 is there. So among these C612 is actually stable one and C613 is unstable one itself. That means same type of the element, same type of the nuclei, same atomic number is there, but it consists of the what means different kind of the what means neutron number itself. And based on the different number of the protons as well as the what means this number of the neutrons, these nuclei is actually classified into the different groups. For example, isotopes are there. So in the isotopes, you will get the same atomic number but with different mass number. For example, 1H1 is there, 1H2 is there, and 1H3 is there. So same atomic number is there, but different mass numbers are there. And second category is actually isobars. Here you will get the same mass number, but with the different atomic number itself. That means different in nuclei. Here hydrogen is given, here helium is given. But hydrogen and helium here having the what means same mass number, but what is different means atomic number is different. So those kind of the elements actually can be called as what means nuclei can be called as what means isobars, and as well as what means next isotones. That means the nuclei which are having the same number of the neutrons is simply called as what means isotones itself. And if you calculate the number of the neutrons that are present in the nuclei itself, for example, nitrogen 717, oxygen 818. So in that, how many number of the neutrons are present in both cases means 10 number of the neutrons are present. And the last one is actually here isomers. Isomers are nothing but same atoms. Same atomic number will be there, same mass number will be there, but their nuclear energy levels will be different. So one will be stable, another will be unstable. That unstable one may become the stable one at any time by giving the what means some kind of the radiation itself. So like that, actually a different kind of the nuclei we will classify. And next, atomic mass unit. What is the atomic mass unit? So before going through this, first of all, as we discussed it so far, so inside the nucleus, what are there? Protons are there as well as the neutrons are there. So what is the mass of the proton if you actually check into it? Mass of the proton is equal to, you will get 1.6727 into 10 to the power of minus 24 grams or minus 27 kilograms. Similarly, mass of the neutron is equal to 1.6750 into 10 to the power of minus 24 grams. That means these values are very, very actually small. So in order to express the masses of all these nucleons, so we are going to introduce a small unit which is called as what means atomic mass unit like that. So atomic mass unit 1 AMU will be defined as it is equal to the 1 by 12 times to the mass of the 1 C612 carbon atom. If you take the one carbon atom, C612 carbon atom, and if you take that mass, and 1 by 12 of that mass is equal to simply called as what means one atomic mass unit. That means we have some reference in order to what derive the one unit itself. So here we are going to take a reference as what means C612. C612. Then how much this mass will be comes out? We know that for any element or for any nucleus or for any atom, if you take the mass which is equal to the what means its molecular weight in a CGS system, that is 12 grams. 12 grams of actually carbon will be consist of the what means Avogadro number of the atoms, that is equal to 6.023 into 10 to the power of 23. Actually, we do not require that value itself. Okay, no issue. So Avogadro number, that many number of the what means atoms will be present. Then what is the mass of the one carbon atom? One carbon atom mass. Very simple. One carbon atom is equal to how much mass? That mass is equal to is nothing but 12 grams by Avogadro number. So if you substitute this value in this equation, so you will get 1 AMU is equal to 1 atomic mass unit is equal to, so 12 will be gets cancelled. You will get 1 by 6.023 into 10 to the power of 23. And if you simplify this one, you will get 1.36 into something. You will get minus 24 grams or 1.66 into 10 to the power of minus 27 kilograms. Not working. So minus 27 here. So when you know the one atomic mass unit value itself, now all these values, the masses of the proton, neutron, and electron will be easily expressed in the terms of the what means AMU. So here that value is already given here. One proton mass in the terms of atomic mass unit, 1.007316, and neutron 1.008701, and electron is equal to 0.000549. So no need of remembering these values. These values will be given directly in the problem itself. The only thing is you have to use those values for getting the solution. But the only thing you have to understand here that the mass of the neutron is slightly greater than the what means mass of the proton. Mass of the neutron is slightly greater than the mass of the what means proton. This you should remember. So this is actually what we discussed so far, atomic mass and properties of the nucleus. What kind of the properties actually we have? Number one, we have to find out what is the charge of the nucleus. Next, we have to know what is the size of the nucleus. And the next, we have to understand about the what means the density of the nucleus also. Now, the nucleus actually consists of the what means protons and neutrons. So, what would be the charge of the nucleus? The charge of the nucleus is equal to anything but Q is equal to. So, neutron means neutral charge, no charge. Proton is having the what means positive charge. How many number of the protons will be there in the given nucleus? We know already Z number of the protons will be present. So now the charge of the nucleus will become how much means Z into E, divided to right, plus Z. Nothing but, for example, oxygen 816. So what is the charge of the this oxygen nucleus means? So 8 number of the protons into charge 1.6 into 10 to the power of minus 19 coulomb. So the only thing is you have to understand is the charge of the nucleus is equal to positive. And moreover, in the alpha, Rutherford alpha scattering also, we have taken the charge of the nucleus is equal to ZE itself only. Sure. Now when come to the size. So when you observe this nucleus, obviously it will be in the spherical shape itself only. Now its size will be, that is, if you take, for example, mass will be depends upon the what means the mass of the what we say proton number as well as the what means neutron number, that is equal to what means mass number A. But as the nucleus is in the spherical shape itself, mass is equal to, actually you can write as what means density into volume. That is, the volume of the nucleus will be proportional to the what means, we get what means mass number, that is equal to A. As it in the spherical shape, the volume of the sphere is equal to nothing but you will get how much means 4/3 pi R cube. So as the volume is directly proportional to the R cube, and again you can write R cube is proportional to what means mass number A. So the radius of the nucleus R is equal to, now we get as proportional to A power 1/3, or R is equal to, you will get some R naught into A power 1/3. This is very, very, very important relation, which is very useful while solving the problems. Here the R naught is equal to, actually called what means one constant. This value is equal to, you will get R naught is equal to some 1.2 into 10 to the power of minus 15 meters. Here 10 to the power of minus 15 meter we will represent as a what means with another unit, that is called as a Fermi, that is about 1.2 Fermi. So this is the radius of the nucleus. R is equal to R naught into A power 1/3 itself. So this is very, very important. While comparing the radii of the different nuclei itself, so you can write the equation as R is proportional to what? A power 1 by 3. So when you compare R1 by R2 is equal to, you can write A1 by A2 power 1 by 3. You can write. So this is very, very important relation. And if you want to compare the what means with respect to the value, V1 by V2 is equal to, we get what means A1 by A2 itself by using this relation. And masses also, obviously you can compare. Okay, next we go to the we go through the what means density. Density is equal to what actually? Density is equal to nothing but the mass of any object per unit volume. So in a given unit volume, how much mass is actually occupied? So that is simply called as what means density. So interesting value actually you will get when you find out the density of this nuclei. That means the nuclear matter we have the different kind of the density. In general, what is the density of the water means you will get some 1000 kilogram per meter cube like that. And what about the metal means some 8000 or 9000 kilogram per meter cube actually you will get. But when you take the density of the nuclear matter, you are going to get in order of 10 to the power of 17 kilogram per meter cube. So for example, let us calculate that. Okay, we will calculate by rubbing this one. So density is equal to what means mass by volume. What is the mass of the nucleus? Mass of the nucleus is nothing but masses of the protons as well as the what means neutrons. Let us assume the mass of the proton and the mass of the neutron is almost equal. That means totally a number of what means nucleons will be present, and either you can write mass of the proton or mass of the neutron by volume. Volume is equal to, you know, that 4 by 3 pi r cube. So R is equal to, already you know what can write, A into mass of the proton by 4 by 3 pi into R is equal to R naught cube into A. So A will be gets cancelled. How did you get this one? We know that R is equal to what? R naught A power 1 by 3. Since R is equal to R naught A power 1 by 3, then R cube obviously will come R naught cube. A power 1 by 3 power 3 means we will get A only. So at last, what you are going to get? EMP by either mass of the proton or mass of the neutron. Almost we assumed equal. So we'll get 4 pi R naught cube itself. You check it. Now the density of the nuclei, if you find out, it is independent of the what means mass number. So it only depends upon the what means either mass of the proton or mass of the neutron. And R naught already we given, it is a constant value itself. So if you substitute all the values and if you find out its value is equal to, you will get some 2.29 into 10 to the power of 17 kilogram for what means meter cube. So the nuclear matter will have the what means very, very, very high density. So in order to understand how much it is actually very heavy when you compare with the general elements which we observe in the daily life itself, means for example, let us have a look here. I think we have written that one. For example, let me take a small cube. Offside is equal to 1 centimeter, or better to understand more clearly. So we take 1 meter. Side is equal to 1 meter. A cubical box this is. Just like the carton actually that is available in our home. Say side is equal to how much cubes? 1 meter. Then what is the value of this cube? B is equal to, look at how much means A cube, that is equal to 1 meter cube. Let us say it is completely filled with the what means water. When it is completely filled with the water, how much actually it will be weighed? That is equal to M is equal to density into value. That is 10 to the power of 3 kilogram per meter cube into this is the density of the water. And this cube volume is already given 1. So we'll get 1000 kilograms only. 1000 kilograms. That can be easily lifted by the 5 or 6 persons. Simply one can lift that one. But when that cube is actually filled with the completely with the nuclear matter, then how much actually it will be weighed? So if you observe carefully, mass is equal to again density into value. So let me take the order is 10 to the power of 17 itself. So 10 to the power of 17 and value of this cube is equal to 1. Now we cannot imagine, and it is highly impossible, or there is no availability of any such a crane in the entire world to lift this much of the mass itself. That means even this much of the size of the cube, which is packed with the nuclear matter itself, it will be more heavy. It will be very, it's not possible to predict even that much of the weight also. So this kind of the density actually will be observed in the black holes itself. So because of that highest gravitational power, so many other stars will be actually go around it. So that only will be observed in the case of the black holes itself only. So these are the properties of the nucleus itself. And besides that, inside the nucleus, actually neutrons are there as well as the protons are there. They also will be rotate about their own axis of rotation. And because of that every nucleus will have the what means their spin, individual spin also they will have. So which is not so much important to us for present current study itself. So let me close here by telling all these properties of the nucleus. Then come to the next one. Mass energy equivalence. So this is the general discussion. After this, we'll go to the what means binding energy. What is the mass energy equivalence? I think Einstein given this statement. Any kind of the mass or any mass can be converted to the energy, and energy also can be converted to the what means mass itself. So if m amount of the mass is there, you see, m amount of the mass is there means I am just assuming it, which is at the what position means rest position. So for example, this pen, when actually it will be converted completely into energy by means of some experimental process itself, then how much energy actually it will be given. So that is equal to nothing but E is equal to what means mc square itself. So this is the mass energy equivalence formula. This is very, important. For example, if there is a 1 kilogram mass is there. So if I completely convert into what means energy, how much energy will be liberated, or the rest mass of energy, that is 1 kilogram mass, how much energy it will be consist means E is equal to 1 kg into C means 3 into 10 to the power of 8 meter per second whole square. Remember here C is equal to what means speed of the light. So how much amount of energy will be come out means 9 into 10 to the power of 16 joules. Why we are discussing this one, just now we come to understand. For example, 1 gram of mass is there. How much equivalent of energy actually you will get? 1 gram means we will get 10 to the power of minus 3 kilograms into 9 into 10 to the power of 16. That is, we will get 9 into 10 to the power of minus, not minus, plus 30 joules of energy actually. 1 microgram is there. How much you get? E is equal to 1 micro means 10 to the power of minus 6, gram means 10 to the power of minus 3 kilogram, and C square 9 into 10 to the power of 16. This much joules actually you will get, that is 9 into minus 6 minus 3 minus 9. So into 10 to the power of actually we get how much means 7 joules. This much of energy actually. But in nuclear reactions, and when you take the what means nucleus, you know that the mass in the order of what means 10 to the power of minus 27 kilograms itself only, or in the terms of atomic mass unit itself. When one atomic mass unit of actually mass is actually converted into the energy, or 1 AMU is equivalent to how much of energy if you calculate, that is E is equal to 1 AMU, how much energy actually consists. So E is equal to, you will get M into C square. Now in the place of the mass, I should write 1 AMU. 1 AMU is equal to, previously we derived some 1.66 into 10 to the power of what means minus 27 kilograms. 9 into 10 to the power of 16. This many joules of energy actually you will get. And again, here energy also you are getting in the units of joules, but very, very smaller value you are going to get. So in order to make it very clear, we are going to convert this energy into what means from this joules unit to what means in another unit, which we can call as what means electron volt. So when I convert this 1 joule of energy into what means electron volt, then what should I write means 1.66 into 10 to the power of minus 27 into 9 into 10 to the power of 16 by, I should divide this into with what means 1 electron volt value, that is 1.6 into 10 to the power of minus 27. 1 electron volt, not 27, actually minus 19. The value of 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. So to convert 1 joule of energy into electron volt, I should divide this term with the 1.6 into 10 to the power of minus 19. And if you calculate all this thing, you will get how much means some 931.5 mega electron volt. That means whenever one atomic mass unit amount of mass is actually converted into energy. So how much energy will be released means 931.5 mega electron volt. This value is very, very important while discussing about the what means stability of the nucleus and the binding energies, as well as the what means mass defect also. So this is very, very important. Have a look at once. Chalo. Mass defect and nuclear binding energy. So the biggest question is, when are the nucleus will be consist of protons and neutrons? In the static electricity, we studied that among the like charges, we get the what means a force of repulsion. And in between the what unlike charges, we get a force of what means attraction. That means inside the nucleus, that means in very, very small space, about 10 to the power of minus 15 meter. Even you cannot imagine that much of the small space itself. In that small space, protons are there as well as what means neutrons are there. Okay, let us forget about the neutrons. Protons are there. But among the protons, you will get what a tremendous amount of the what means Coulomb repulsive forces. So definitely due to that Coulomb repulsive forces, this nucleus should become what means unstable. It should become unstable. But if you observe carefully, most of the elements which are available in the nature, so will be actually stable. That means against these force of repulsions, something is going to be converted into what means energy to hold the what means all the protons and also neutrons together itself. Then who are supplying that much of the energy, and how the energy is actually gained by the nucleus itself? That easily can understand what means mass and effect. Actually, what is the mass of the nucleus? If anybody asks you, then what will you say? It is simply the total mass of the protons as well as the what means neutron itself. So that is actually called as a what means calculated mass. The mass which we calculate for a given, for example, x, z, a is there. What is the calculated mass means? Z into what? Mass of the each proton EMP plus neutrons are there, that is A minus Z, that is equal to Mn. This is actually what means calculated mass. But if you measure experimentally the mass of the nucleus, given nucleus, that will be different. Mass of the nucleus. Then how much value it will be, sir? That value will be little bit less than the what means calculated mass itself. There will be some difference in the actual mass of the nucleus to the what means a measured mass. Then where this mass actually gone? That mass is actually called as the what means mass defect, that is equal to what means delta M. Delta M is equal to is nothing but calculated mass of the nucleus to the actual mass of the nucleus. This is called as a what means mass defect. Then where this mass is gone? Just now in the previous discussion, we came to understand that a certain amount of mass will have the what means certain amount of energy. So this whatever may be mass is actually disappeared here in the form of the mass defect, that will be converted in the form of the what means energy to hold the what means all the nucleons together itself. Actually, that kind of the energy is called as the what means binding energy. That means for a given nucleus, how to calculate the binding energy means very simple. First of all, you have to calculate the mass defect, and later you have to multiply it with the what means C square. Then you can easily understand the amount of binding energy had by that particular nucleus itself. But actually, what is the amount of energy will be released for whenever one atomic mass unit of energy actually disappears? Already we calculated it is about some 931.5 mega electron volt like that. So if you measure delta M mass defect in the terms of the what means AMU, then easily you can write equation delta M into 931.5 mega electron volt. This much will become the what means binding energy of what a given nucleus. However, we will calculate the mass defect in the terms of the what means atomic mass unit itself only. So if we get, for example, in the given nucleus XZA, say mass defect is equal to got some 0.05 AMU. Then what is the binding energy of that particular nucleus means? Simply 0.05 into 931.5. So if you multiply this one, you will get that much of the binding energy of the given nucleus itself. So like that we can calculate. So what important thing that we are getting from the information of mass effect means we are able to understand the binding energy of the given nuclei. So what happens are then if you know the binding energy, if more binding energy is there, then you can understand that whether it is stable or not. More binding energy, it is more stable. Less binding energy, it will be very less stable. From that, you can understand that whether the given nuclei will be undergo the process of nuclear fission or the nuclear fusion, or will be involved in the artificial transmutation or not. That things also we can easily understand by knowing the what means mass defect as well as the what means binding energy itself. And if you want to write this equation in the terms of the mass of the atom like that, so what is actually here left means only electron is left here. So how many number of the electrons are left means already you know Z number of the electrons are actually left, even if you calculate that one plus A minus Z into Mn, then this total will become what means mass of the what means atom itself Z into what I can write, mass of the what means one hydrogen atom, and here also mass of the nucleus. Here I added ZME, so I should minus M nucleus plus ZME. Minus you will get what means. So let me write this equation very clearly instead of writing in zigzag way. For example, here we did not consider the what means the mass of the electrons itself. So if you introduce that one also, here only the calculated mass of the what means nucleus. This is the measured mass of the nucleus. But when you actually write in the terms of the what means mass of the atom and mass of the nucleus and so on, so like that. So how to write that one is very simple. ZEMP plus ZME plus A minus Z into Mn. And water may be added, I have to subtract here. Mass of the nucleus plus mass of the all the electrons ZMP. If I take Z common, mass of the proton plus mass of the electron plus A minus Z into what means Mn minus, this is nothing but the measured mass of the what means atom. So let me call this is equal to M. Now this is nothing but one mass of the proton, one proton mass and one electron mass is equal to nothing but hydrogen mass. That is equal to nothing but ZAMH plus A minus Z into Mn. Now see, I have calculated the total mass of the what means atom minus the measured mass of the what means atom. That also gives the what means the mass defect. This is also correct. So this also can be used to find out the what means. Whenever in the terms of the mass is given in the terms of the atom, then we can use this equation itself. So this is the mass defect as well as the what means binding energy. Here you will get one term which is called as the what means binding energy per mass number, which is called as what means average binding energy. Let us discuss that one in the next slide. Binding energy curve. We have so many elements, and if we calculate their binding energies per nucleon, that is binding energy per mass number, then you will get this kind of the figure and gives the very important information to us. So these are the all elements, whatever maybe we have taken up to the what means 92. A mass number is equal to what means some to whatever till to that number actually we have taken. And if you observe carefully in this, iron 1, if you observe carefully, it is having the what means highest binding energy per nucleon. That you are going to get means about some 8.8 mega electron volt. So it is the one of the not one of is only one element which has the what means highest binding energy. So it is more stable one. As I told previously to you, when you know the binding energy and as well as the mass effect, then you can understand that whether the given element is more stable or not. So if you observe the elements from the mass number 40 to what means 160, all these will have the what means binding energy values more than 8. So almost these will not actually involve in the what means nuclear reactions or in artificial transmutation itself. But when you take the elements less than the mass number 40, all these lithium, beryllium, boron, helium, carbon, neon, and chlorine, fluorine, all these will be have the what means very less amount of the binding energy itself. Definitely these can be involved what means in nuclear reactions. These are a little bit unstable when you compare with the stable nuclei. And if you go to the other elements whose mass number is more than the what means 160, So all these elements which will be fall after the 160 mass number, those also will have the what means binding energy very less values. So these also will be involved in the what means nuclear reactions. In precisely here, combination of the nuclei will be take place, combination and giving what means some stable nuclei itself. Such kind of the nuclear reaction will be take place. And but whereas here, splitting of the nuclei to give the what means stable nuclei will process will be take place. And you know that this kind of the process is called as the what means nuclear fusion, and where this is called as the what means nuclear fission. Now we can understand that very easily by from this binding energy curve. So which elements will be easily involved in the nuclear fission process and which elements will be involved in the nuclear fission process. As you know very well, uranium 9235 will be used in what means where? In atom bomb. But whereas hydrogen will be used in the hydrogen bomb. There the principle that is involved there here means nuclear fusion, but whereas here nuclear fission will be take place. That kind of the information you will get from the what means binding energy curve. And next what nuclear forces. So in the previous slide we discussed that some energy is actually is used because of the mass defect. Some energy, some amount of mass is actually converted to the energy to hold all the nucleons together. Not only that much of energy, but also some other forces also will be involved in holding all the nucleons together. Those forces are actually called as what means nuclear forces. The first one is what? Coulomb repulsive forces. You know that inside the nucleus there are what protons are present. Among the protons we get the what means repulsive forces, and because of that there is a possibility of instability in the what means nucleus itself. So Coulomb forces are actually responsible for the instability of the nucleus itself, and these are the purely repulsive forces only. Only you will get among the what means protons. There is no such forces among the what means neutrons itself, being they are what means charged less. And coming to the next one is nuclear attractive forces. This is very important. Among the nucleons, irrespective of the charge, whether it is a proton, whether it is a proton, neutron, or neutron, there will be strong force of attraction will be present. That strong attractional force is actually called as what means nuclear force. So in the universe, what is the highest the force which is have the highest strength means attractive force means that is nuclear force itself only, and of course this force only will be present inside the what means nucleus of the atom only. So with respect, these are actually charge independent among the proton neutron, and neutron. You will get the what means strong force of attraction, and these forces only will be play a crucial role when the distance is actually in the order of what means 10 to the power of minus 15 meter itself. As you already discussed, the size of the nucleus is also in the order of the minus 15 meter itself. So in these distances, so you are going to get the what means the strong nuclear force of attractions. For example, proton is there, and proton neutron is also there. Proton neutron is there. So proton is actually repelling because of the what means Coulomb repulsive force, and also proton is attracting because of the what means nuclear force of what means attraction, that is nuclear force itself. And if you take the proton and neutron, there is no Coulomb repulsive force. Only you will get what means nuclear force of attraction only. Because of this attraction, they will come very close to each other. And even if you take the neutron, there is no Coulomb repulsive force. They will come very close to each other. But how close they will come each other, that is very important. When the distance is actually rapidly decreases more than the what means some 0.5 or 1.5 to 10 to the power of minus 15 meter like that, then these nuclear attractive forces will be turned into the what means repulsive forces itself. That means same nuclear attractive forces will become the what means hardcore repulsive forces. That means these nuclear forces does not allow the nucleons to come very close and collide with each other, as well as does not allow to move very far from the each other itself. They will maintain the what means a stable kind of the water structure in the inside the nucleus itself, so that they will maintain the what means a particular shape, or they will maintain the particular size itself. So these are the actually very important nuclear forces. And of course, along with that, we have the another kind of the force which is called as a what means a tensor force. Already I told to you, not only these neutrons, protons, not only electron which will be revolve around its own nucleus, around its own axis, but also these protons and neutrons also will be revolve around its own axis itself. And because of that, you will get the what some magnetic movement, and because of that, among the nucleons also you will get the kind of the force of attraction, so which can be called as what means tensor forces itself. So these are the nuclear forces that will be involved inside the nucleus itself. Very important. And because of all these combination of these forces only, stable nuclei are present. What means in the universe itself. If no force is available, or if any force, only one force will be dominate, then definitely the nuclei will become what means unstable. So all the forces will be balanced in such way that to make the nucleus stable. Next, we have the what means radioactivity. What is the need of discussing the radioactivity? Just now we came to understand that there are so many elements are present in the universe, and different nuclei have the one different kind of the properties, different kind of the mass effects, different kind of the binding energies, and some of them are actually stable, some of them are unstable. So always the nuclei want to become a what means a stable one. So when you understand the about the what the elements which are with a high mass number itself, for example, if you take the uranium 92 238. That means within the small size, within the small size, in the order of the what means 10 to the power of minus 15 meters, how many number of the nucleons are present? Means 238 number of the nucleons are present. And what kind of the forces also present already? You know, four types of the forces are actually involved inside the nucleus among the nucleons itself. At one stage will be take place where the hardcore repulsive forces or Coulomb forces will be dominated than the what means attractive forces. At that instant, what happens means in order to want to become the stable, this nuclei will be gives out the what means certain number of the what means protons and neutrons and some gamma rays will be comes outside like that. That means the spontaneous emission of the protons, neutrons, as well as the some another energy rays, that can be called as the what means radioactivity. This is happens by itself only. So because of this is actually called as the what means radioactivity or radioactive decay. So what will come actually? And the charged particles which are coming outside, or the uncharged rays which is coming outside, what we call, and when that will be come outside, what kind of the changes will be takes place in the nucleus, that we can understand. So from the heavy nuclei, just now I told you that some types of the rays will be come out, or some type of the charged particles will be come. These are actually taken into what means three groups. One is alpha, beta, gamma rays itself. Alpha ray, beta ray, as well as what means gamma ray. So first of all, let us discuss the what means alpha. Actually, helium nucleus is called as the what means alpha particle. Helium nucleus. I'm telling it is the nucleus. In the helium nucleus, what will be there? Two protons will be there, two neutrons will be there. That means from this heavy mass element, whenever one alpha particle will come outside in order to get the stability, then what happens? For example, X is a given element, and from that element, what you are going to get? Helium atom actually, or helium nucleus actually, you are going to get. Helium nucleus is nothing but what means alpha particle, helium. Now, of course, some energy also will become outside. Actually, a single alpha particle will not come outside, and along with that, some energy may be come out, beta particles also may come out, and so on like that. So, for example, alpha particle came in order to understand some simple information. So, here what happens? You see, in order to balance the equation, here already two protons came outside. Since the beginning, we are telling that the atomic number is equal to what means the number of the protons which are present inside the nucleus itself. That means proton number is decreasing Z minus. When the proton number decreases, obviously atomic number changes. This element also will be changes. Why? Z minus 2. And mass number, alpha particle mass number is equal to 4. So the product nucleus mass number also will be what happens means decreases A minus. So Z minus 2 will become its atomic number. A minus 4 becomes what means mass number itself, X, Z, A. So this kind of the thing will be take place whenever the alpha particle will be come out from the what means nucleus itself. And while solving the problems, I will tell you, let me take this, initially it is a rest position, that is kinetic energy is equal to 0. And whatever maybe energy is liberated, let me say, is shared by the both, what we say, product nuclei as well as the alpha particle. Then what will be the kinetic energy of the alpha particle and also as well as the work means product. So that we will do in while solving the problem itself. So presently you try to understand that whenever the alpha particle will be come out from the nucleus itself, the nuclei will be changes. It will become the new element whose mass number is equal to 2 times Z minus 2. That means it decreases by 2, and whose mass number will be decreases by what means 4 itself. For example, if I say that some Y is there, Z A, say I told to you that from this you got the two alpha particles. Then what will become the product in nuclei? Simple. Say new nuclei are going to get to balance the equation. Here atomic number is equal to means Z. Here two alpha nuclei actually came outside, 2 into 2, that is equal to 4. This will become how much means Z minus 4. Obviously this will become how much means A minus 8. So in periodic table, how that element will be goes, one can easily understand that one. Here atomic number is actually decreasing means it will be shifted to the what means left side in the periodic table itself. So this is about the what means alpha decay. Okay, I have given one problem here. Okay, let us solve this problem first. Before going through the beta decay, so let us go through this problem. So, a nucleus disintegrates into two nuclear bonds which have their velocities in the ratio 2:1. Then what is the ratio of their nuclear sizes? Velocities are given, he is asking the sizes. But we did not discuss about this velocities and so on, so on. But we can get this problem very easily. The mechanics already have studied that when the bomb is at rest and explode into what means pieces. Explode into what means pieces. Here bomb is exploded because of the what means internal forces only. So internal forces does not alter the what means the linear momentum. Law of conservation of linear momentum already you know. If there are no external forces acting on the system, the total linear momentum of the system is remain constant. So initially the bomb is at rest means initial momentum is equal to 0. But after explosion, many number of the parts actually moving in different kind of the directions. Then the algebraic sum of the all moments must also be equal to how much means 0. Then what should I write here? Say its momentum is equal to P1 bar, P2 bar, P3 bar, and P4 bar. That is P1 bar plus P2 bar plus P3 bar plus P4 bar is equal to how much means 0. This is the basic idea in solving the what means such type of problems. Here one nucleus is there, a bomb is there, nucleus, which have their, it is split into how many parts? Two parts. Only two parts are given to you. Say one mass is equal to m1, other mass is equal to how much means m2. Say total mass is equal to m. Now this fly off with different kind of the velocity, say for example v1, v2, which are in the ratio of what means 2:1. That is given to you v1 is to v2 is equal to how much means 2:1. Now asking what is the ratio of their nuclear sizes itself. So first of all, initially nucleus at rest position momentum is equal to 0. After disintegration, you are going to get what means two parts, that is m1 v1 plus m2 v2. It is actually vector quantity, so m1 v1 bar plus m2 v2 bar, that must be is equal to how much means 0. So what I can write from this, m1 v1 bar is equal to m2 v2 bar. Of course, you will get the what means negative sign. Negative sign indicates what? These two velocities are in what direction? Opposite direction. So in the vectors, if you get anywhere minus, you have to understand that negative sign indicates the what means opposite direction itself. That means whenever this nuclei will be split into two parts, one part it goes in this direction, other part should go in the opposite direction. Quietly it should move in the opposite direction. Of course, the magnitude may be different, but the direction should be in the opposite direction itself. Chalo. Now m1 by m2 is equal to what should I write? v2 by v1. I am writing only the magnitude. So m1 by m2 is equal to v2 by v1, v2 by v1, v1 by v2 is equal to given to you 2 by 1. Then v2 by v1 is equal to get how much means 1 by 2. He's asking what means the size. That means let us get the values in the terms of the what means a radius. So mass is equal to, already you know that, density into volume. Mass is equal to density into what means volume. Now m is proportional to what means value means already you know. Already you know that the density of each nuclei is actually almost the same. So no need of bothering about that. So 4 by 3 pi r cube. Now m1 by m2 is equal to, can write r1 by r2. That is m1 by m2 is equal to, right, r1 by r2 whole cube. That is equal to 1 by 2. Now the ratio r1 by r2, that is the ratio of these sizes, actually you will get 1 by 2 power 1 by 3. It would be your answer. So nuclear physics is there and mechanics is there. This is a remix problem. So you must understand the concept of every chapter. Then you can apply that anywhere. So this is the one problem that we discussed here. Now let us go to the what means beta decay. And we have some other problems also. Let us discuss it. Now beta decay. That means from the nucleus itself, we are again going to get some radiation in order to get the what means stability. Here, beta decay actually we can understand into two ways. That is negative beta decay, positive beta decay. At last, we'll discuss what is the electron capture itself. Negative beta decay. Okay, now this is a heavy nucleus. For example, let me take uranium, 92, 238. 238, that is protons and neutron number is there. Again, it wants to what means become stable. Now to get the stable, now not only alpha particles, it is also giving the what means beta particles. Beta particles are nothing but what means electrons. Beta particles are nothing but what means electrons. Better to say as negative beta decay. Actually, where are the electrons are present? Electrons are actually revolving the what means around the nucleus only. Electrons are revolving around the nucleus only. So we expect that electrons are actually coming from the energy levels itself. No, these are not the electrons which are coming out. These are the actual electrons which are coming from the inside the nucleus. How that will be possible? Inside only proton, neutron is there. Then how the electron will be come out? So we already discussed it that the intention of this nucleus is what? To become stable, being it is a very, very heavy. So what happens? One of the neutrons will be split as proton, electron, and antineutrino inside the nucleus. One of the neutrons, what will do to get the what means stabilize? Neutron will be turns into what means proton, electron, and antineutrino. This proton will be remain in the nucleus itself only, but this electron and antineutrino will be come out of the what means nucleus itself. So this electron order may be coming outside. That is called as a what means negative beta decay. And because of this, what is going to happen to that nucleus? Let us check that one. Say for example, XZA. From that actually you are getting what? Electron. And what you are getting what? Antineutrino. Now what is happening here? This is -1. In order to make or balance the equation here, number of the protons right hand side is left hand side is Z. Here also it should become what means total should be Z only. So I should make it is what as Z plus 1. So atomic number is changing. That means you are going to get the what means new element that is equal to Y. But you see, already I told you neutron and proton both will have the what means same mass. That means mass number does not change. So this kind of the thing will be takes place during the what means negative beta decay. Now in the periodic table that the nuclei will be shifted to the what direction means right direction, that one can easily understand that. So this is called as what means negative beta decay. But sometimes not only this electron, some positron also will be come out from the nucleus itself, which is actually called as a what means antiparticle of the electron, positron. Antiparticle means what? It has the same as that of the electron, but has a what? Opposite charge, that is equal to what means positive charge. At the time that can be called as a what means positive beta decay. At the time, actually, what kind of the change will be takes place inside the nucleus? What particle will be make that positron to come outside? So here, what happens means proton will be changed as a neutron and positron. Along with that, neutrino will be come outside. Check carefully. Proton is going to be turned into what means neutron. And resultantly, you are getting what means a positron as well as a what means neutrino. So neutron will be just remain within the nucleus itself only, but positron as well as the neutrino will become outside. But when you take this reaction or this kind of the disintegration, one can easily understand that as this is more mass when you compare with the what means a proton mass. Neutron will have the more mass, already we have seen. It has a very less mass. So because of the, as there is a decrease in the mass itself, energy will be come out. However, that electron also will be come out. But this is happening reversely. In this nuclear reaction, mass is going to be created. Proton actually has the less mass, neutron has the more mass. Is that possible? Means yes, inside the nucleus it is possible. Some of the nuclear energy will be utilized to make this proton into what means neutron. This only happens where means inside the nucleus only. But this will be happening even outside the nucleus also. Already we discussed neutron is actually unstable outside the nucleus. This kind of phenomena will be take place. Not only outside nucleus, in the case of the heavy nuclear elements, this also will be take place inside the nucleus. But whereas here, that is positive beta decay only take place inside the nucleus as it has sufficient energy to convert the proton into what means neutron. Now see what kind of the change is going to be take place inside the to the nucleus. So what should I write here the equation? So let me write to where here only I will write what is that? X Z only I will take. What is coming outside? Positron. Along with that neutron. So here +1 is there. Here it will become what? -1. So again you are going to get the what means new nucleus. And there is no change in the what means mass number. So this equation is hard to write whenever you are asked. This is for the what means negative beta decay. This is for the what means positive beta decay. So these are the two important concepts. And the next one is what means electron capture. Electron capture may not become under the beta decay, but it is also a kind of the phenomena that will be takes place in the case of the what means heavy nucleus. In order to get the stability, this kind of the thing also may be take place. What is the electron capture? Electron capture. It is also for making the nucleus what means stable. For that reason only it is also happening. So this is also again will be takes place in the case of the what means heavy nuclei. Whenever the nucleus have very highest number of the what means protons, it creates the what means strong positive electric field. This strong positive electric field, what it does is it will pull the electron into the what means nucleus. It will pulse. Actually, more number of the protons means more number of the electrons also present, which are revolving around the nucleus in the different energy levels itself. But which electron is very, very near to the nucleus means the electrons which are present in the either K shell or L shell. Now, the electrons which are revolving around the nucleus closely, that will be pulled by the what means this is strong electric field created by this proton itself. Then what happens? One proton plus one electron obviously gives what? Neutron, and in neutron some energy will be released. Energy will be released. This kind of the thing will be take place. So when you want to write this equation X, Z, A, what is happening? Electron -1, 0. Now see, proton number is decreased. So you will get nu1, Z -1, but there is no change in the mass number A and neutron as well as the what means some gamma rays will come outside. That kind of the equation you require to write during the what means electron capture. So all these alpha decay as well as beta decay, beta positive or beta negative decay, or electron capture or gamma decay, all these processes will be take place simultaneously until that heavy nuclei will be what means to become it will become stable. This process will be take place spontaneously, and hence this is called as what means a spontaneous disintegration of a nucleus. Process is actually called as what means a radioactive decay. And when come to the gamma decay itself, gamma rays are nothing but what means electromagnetic rays. These are electromagnetic rays. So it does not have any kind of the mass as well as what means any atomic number and so on, charge, etc., like that. Simply, whenever gamma rays are coming from the nucleus itself, there is no change will be in the what means atomic number. There will be no change in the what means mass number also. Sometimes gamma rays itself will be come out from the nucleus. I think in isomers we already discussed. So same type of the nuclei itself, but what happens one nuclei may be in the higher state, higher metastable state. At the time, what happens by giving out some gamma rays, it may come to the ground state and it will may become the what means a stable one like that. So in such cases, so this gamma rays will be comes out, and of course in every alpha decay, beta decay, in all these decays itself, along with the alpha beta particles, gamma rays also will be come out. That we should remember. Law of radioactive decay. What actually we are discussing? We are discussing about the stability of the heavy nucleus. A nuclei wanted to become what means stable because of many reasons. Since it has so many number of the more number of the what means nucleons inside, because of much force of repulsion among the protons as well as the hardcore repulsive forces, it want to become stable. And because of that, some of the nuclei of that given element will try to start giving the what means alpha rays, beta rays, as well as the what means gamma rays. In a given element or in a given specimen or in given sample, more number of the nuclei will be present. How many number of the nuclei will be present? Already we discussed. When you know that molecular weight of that given sample or specimen itself, easily we can calculate the mass of the specimen. When you know, easily we can calculate what means the number of the nuclei present in the given sample also. How we calculated that one? If m is the molecular weight is taken in grams, then Avogadro number of the molecules will be present. For example, if m is the mass of the given specimen, then how many number of the moles will be present, mass of the specimen by molecular weight. This many number of the what means number of the moles will be present. So how many number of the molecules will be present means in 1 mole Na, then m by n mole you will get Na. So this is the number of the what means molecule nuclei that are present in the given sample itself. This we can easily calculate. But which nuclei is going to be disintegrate into other, that we cannot expect. So this law will be gives some information about the rate of decay of the nuclei in the given sample itself. This is called as what means law of radioactive decay. It states that at any instant dn by dt means what? The rate of decay of a radioactive sample will be directly proportional to the number of the nuclei that are present at that time. At that time. So dn is equal to dn by dt is equal to right is equal to, we get the what means lambda n. Okay. Now if you want to integrate this one, dn is equal to, we get lambda n into dt. Here, as the number of nuclei are going to be disintegrate or decrease, you can keep what means minus n itself also, nothing will be happens. So dn by n is equal to, you can get what means minus lambda into dt itself. Here negative sign indicates what? The number of molecules are going to be decreased. That is disintegration is going to be disintegration of nuclei will be going to be decreased. So when you take the what means this integration of dn by n is equal to minus lambda dt integration, and if you follow the steps, I'm not going to elaborate that one. You will get final equation n is equal to n naught e power minus what means lambda t. I'm interested to tell this. N is equal to the number of the undecayed nuclei. N is equal to number of undecayed nuclei at a time is equal to how much means T. N is equal to N naught e power minus lambda T. N naught is equal to what? The initial number of the nuclei. That means when you are going to calculate the decay of the what means given sample, when you started, when time T is equal to 0, then N naught gives the what means initial number of the what means nuclei. This formula is very, very important. This formula further we can write like this. So I can write N by N naught is equal to what means e power minus lambda T, or N naught by N is equal to, you can write what means lambda T. So if you want, we can draw a graph also between time versus what means this number of nuclei that are going to be disintegrate. So initial time, whenever time T is equal to 0, the maximum number of the nuclei are present which are undecayed, and with the time exponentially that disintegration is going to be take place, exponentially increasing like that. So when you come to this, N naught by N is equal to e power lambda T. If I take log base E both sides, N naught by N is equal to, you will get lambda T. Or time T is equal to, I can write, time T is equal to, I can write 1 by lambda into log base E N naught by N, which is very, very, very important equation. While solving problems, this is lambda, no? Yeah. So after certain time T, or at what time T, that N value will become N naught by 3, N will become N naught by 2, N will become N naught by 6, and so on like that. At that time, we can use this equation for determining the what means the time. This is very important. And one more thing I would like to tell here is, I'm going to remove this. I think previously we have written there, if mass is more, the number of molecules also more. That is, M is proportional to what means N. So same equation we can write when the given specimen value given in the terms of the what means masses. So you can write M is equal to what means M naught into e power minus lambda T. That also we can write undoubtedly. And the time value also we can write 1 by lambda into log base E into N naught by N. This also you can write. This I would like to tell. M is equal to M naught into e power minus lambda T, or M naught by M. This also can be written. So this is actually called as the law of radioactive decay. Okay, let's go to the next one. So next we have activity. It is the number of decays per unit time. Actually, this already we discussed in the previous one. This dN by dt, somewhere we have written before deriving this one. This dN by dt is actually called as what means activity. how many number of the nuclei are going to be disintegrate per unit time? R is equal to dN by dt. Actually, you will take the modulus here. That means positive value will be take d by dt. N is equal to, just now we derived what? N naught e power minus lambda t. N naught will become outside. Differentiation of e power minus lambda t means minus lambda e power minus lambda t. So lambda n naught into e power minus lambda t is equal to what? Again n. So the activity of a given nucleus specimen R is equal to what? Means lambda n. It is also very, very important. Next, come to the half-life. The problem with the radioactivity or about the unstable nuclei is, in the given sample, as there are so many number of the nucleons, so many number of nuclei, we don't know which nuclei will be disintegrate in what time. It is not possible to understand which molecule is going to be what, which nuclei is going to be what means disintegrate. It is highly impossible. And how long it will take for the complete disintegration of the what means given sample itself. But surely we can understand that after what time the half of the nuclei will be completely disintegrated. That we can calculate. That time is actually called as a what means half-life. Previously, in the previous slide, we have derived that T is equal to 1 by lambda into log base E n naught by n. So we can use that formula. T is equal to 1 by lambda log base E n naught by n. See the time taken to disintegrate half of the given nuclei in the given sample. That is, n should become what means n naught by 2. Then the time taken will be called as the what means T half. T half is equal to, you will get 1 by lambda into log base E. N naught by n. N is n naught by 2 means we will get what means log 2. So let me write here T half is equal to, now we can write log 2 base E by lambda. Log 2 base E value is equal to what means 0.393 by lambda. 393 or 693, you please check it. So T half-life is equal to, you will get log 2 base E by lambda. This gives the time taken by the given sample to disintegrate half of the nuclei in the given specimen itself. This is very, very important. Here, average life is equal to nothing but the total time taken to disintegrate the total given sample completely. So that value is actually, you will get what means average life is equal to, if we derive that one, that is exactly will become how much means 1 by lambda itself. So this is some information about the what means half-life, average life, as well as the what means activity of the given specimen. Now, let us go through the few problems. So what are maybe concepts we have discussed so far? On these concepts, we are going to discuss the what means problems. Here given the binding energy per nucleon, lithium 37 and helium 24, 5.60 and 7.06 mega electron volt. Now given one nuclear reaction is given, he is asking what means how much of energy is actually released. So what is the process took place here? Lithium 37 bombarded with what means 1 proton, giving what? 2 He4 and one more 2 He4. I will write like this. 2 alpha particles and some energy is coming out. How much energy is coming out, that we have to always calculate. So the simplest thing you have to understand is in nuclear reactions, mass will be what happens means decreases. Mass, if you calculate reactant mass, product mass, if you calculate, the mass of the reactant will be more than the what means mass of the products. Water may be mass defect took place, that will be converted in the form of the what means energy 931.5 mega electron. This thing first of all will be take place. And the second thing is binding energies. Binding energy, reactants, binding energy of the what means products. Why one nuclei will want to actually participate in the nuclear reaction in order to get the what means stability. Here this kind of the process took place means what? Helium is more, having more binding energy than the what means lithium 37. That means in nuclear reactions, the binding energy of the reactants will be less than the what means binding energy of the products. Then how to calculate the energy released here means simple. Binding energy of the products minus binding energy of the what means reactants. This is the simple thing will be take place in the nuclear reactions itself. So where either you have to calculate the decrease in the mass into 931.5 mega electron volt, or you have to calculate the binding energy of the reactants as well as the products, and you have to take the what means difference to find out the what means energy. So this is the simple thing. First of all, we have to understand. And what is happening here, if you see, observe carefully, the binding energy of the nuclei given here. So the binding energy of the helium, just now we discussed that this products will be more than the what means that reactants itself. You find out the total binding energy here, total binding energy here, take the difference. So let me calculate binding energy of the what means products is equal to what is there, 2He4 is there. What is given? The binding energy per nucleon is given. How many nucleons are there in helium? 4 nucleons are there. 4 into, so how much I have to write? 7.06. 7.06. Like that, how many heliums are there? 2 are there. So if you do this one, 8 into 7.06, 86, 87, 56.48 mega electron volt is the binding energy of the what means products. Now calculate the binding energy of the what means reactants, binding energy. What are the reactants here? Proton, and next what means lithium. Proton is a single particle, leave off. Come to the lithium. How many nucleons are there? 7. So how much is given its binding energy per nucleon? 5.60. 7 into 5 point, how much? 60. Now multiply this 42, 37.2 mega electron volt. Now take the difference. If you take the difference, how much you get? Have you done anywhere mistake? You please check it out once. 2 heliums actually you are getting. One lithium is there 37. So we are going to get this much of energy and take the amount of energy released. We don't have, we don't need to keep more brain on this. Simple multiplication is there, simple subtraction is there. You take the subtraction, binding energy of the products minus binding energy of what means reactants, and solve the equation, you will get the answer. So in this nuclear physics, there is no what we say typical problems. The only problems are based on the simple mathematics, multiplications, subtraction, and additions itself. If you are very well about that, then obviously you can do the arcade of the problems. You check it out and take the what we say difference of that one, you will get your answer. Chalo, next. A radioactive material decays by simultaneous emissions of two particles with half-lives 1400 years and 700 years respectively. What will be the time after which 1/3 of the material will be remains? I think already we have given one relation like this. T is equal to 1 by lambda log base E n naught by n. Or I given that T is equal to 1 by lambda log base E m naught by n. Sure. So what is saying here? After what time? What will be the time after which 1/3 of the material will be remains? M must be is equal to how much means m naught by 3. That is T is equal to, you have to write 1 by lambda into log base E. M naught by 3 means you have to write 3. Next, what we have to find out? Decay constant lambda. But here, what is happening? The given nuclei is not disintegrating with a single disintegration constant. Here, half-lives are given, different disintegration constants are given. Lambda 1 is given, lambda 2 is given. Half-life one way is there, half-life in another way is there. Say it is, for example, T1, it is actually what means T2. So at that time, what you have to do? You have to find out the what means average half-life, or you have to find out the average decay constant. So in that we have to substitute. So how to find out the average half-life means you better to remember this formula 1 by T1 plus 1 by T2. So 1 by T is equal to, so one half-life is equal to how much is given to you? 1400 years. 1400 years. Other is given 700. If 700 is x, this will become the 2x. That is 1 by x plus how much means 1 by 2x. That is equal to T is equal to, you will get what means 2x by 3. 2 into x means how much you assumed? 700 by 3. That is 1400 by 3. Now calculate, substitute that value in this equation, find out the answer. I'm not going to do the simplification. This is the method how to solve the what means the problem. Whenever different half-lives are given for a given sample or different disintegration constants are given, then you require to find out the what means average half-life or average decay constants. Lambda is equal to lambda 1 plus lambda 2, whatever maybe you can write. So by using that, you have to substitute in this equation and you have to find out the what means the time. So if you find out the time, you will get the what means some 740.6 years like that. Next problem. A sample radioactive material has mass m, decay constant lambda, molecular weight the capital M. Avogadro number constant is given Na. What is the initial activity of the sample and activity after time t? Two questions are there, asking initial activity and activity after time t. So we have formula here for the activity, where we have done activity. I think there is a problem. Activity R is equal to, we got here lambda n, isn't it? So initial activity means what should I write? Lambda into n naught. How many number of the nuclei are present? That we have to calculate. Mass is given m. Molecular weight is given to you capital M. So these many number of the moles. These many number of the moles. The number of the molecules means you can write m by capital M into n into a. So initial activity is equal to, we can write lambda m by capital M into Avogadro number. This is our answer. Then after time t, r is equal to lambda. N means what? N naught into e power minus lambda t. Isn't it? The same thing we have to substitute here. Already you know lambda n naught, that is equal to lambda n by capital M into NA into e power minus lambda. So this is the activity after time t. That is the initial activity. So like that easily we can calculate. Next problem. The radius of the nucleus of mass number is given to you. A is equal to 64. And radius is given to you. R is equal to 4.8 Fermi. Then mass number of another nucleus having radius 4 Fermi, given 4 Fermi to you. Asking what is the mass number. Say this is A1, R1, A2, R2. Now that is already given to you 1000x. A2 is equal to 1000x. Then what is the x value is actually asking. So how the mass number is related with the radius of the nucleus means already you know. R is proportional to what? A power 1 by 3. Then R1 by R2 is equal to, you can write A1 by A2 power 1 by 3. So A1 is equal to given 64 to you. Of course, this value is given. You write that one 4.8 by 4 whole cube is equal to A1 by A2. So this is related 1.2, isn't it? Or 1 to 1.2. 1.2 into 1.2 into 1.2 is equal to A1 by A2. Why I wrote 1.2? Just now you come to understand. 12 into 12 into 12 by 1000 is equal to A1 by A2. Okay. Now A2 is equal to, you will get 1000 by 12 into 12 into 12. A1. A1 is how much? A1 is given to you 64. So A2 is equal to given 1000 into x. That is x is equal to how much means? 64 by 12 into 12 into 12. Do it, you will get the answer. Simple mathematics, simple multiplication. We come to the next problem then. I think this problem already we had it in the beginning. So let me check out this. A nucleus disintegrates into two nuclear parts in such a way that ratio of their nuclear sizes 1 is to 2 power 1 by 3. I think we have done this one. Their respective speeds have in the ratio n is to 1. What is the value of n? I think this already we have done. Whenever nucleus is going to be disintegrated into what means two parts. So the two parts momentum should be equal in what? In opposite direction. So M1 V1 is equal to, you have to write M2 V2. I'm writing in magnitude, so directions. I remove that. So V1 by V2 is equal to M2 by M1. In such way that ratio of their nuclear sizes, that means R1 by R2 is given. But M2 is equal to what? Mass is equal to volume, isn't it? M is proportional to R cube. So R2 cube by R1 cube. So their respective speeds in the ratio of n is to 1. So n by 1 is equal to, now R1 by R2 is 1 is to 2 power 1 by 3. Then R2 by R1 is 2 power 1 by 3 by 1 into cube. So you will get what? 2 power 1 by 3 whole cube means we get 2. That is n is equal to 2. You will get answer. This we are already done. Next, let us go through this problem. Simple question. I think just now we discussed the same problem itself. When uranium-238 nucleus originally at rest decays by emitting an alpha particle having a speed u, the recoil speed of the residual nucleus is equal to how much? Just now we discussed it. This is the nucleus. Originally at rest, initial momentum is equal to 0. Now from the nucleus, alpha particle is coming outside. Alpha particle is coming outside. Then what happens already know, alpha particle will become out like this. And the nuclei will be goes like this. Now, what is the mass number of the alpha particle means already 4 units I am taking. I am not taking in the kilograms or AMUs like that. Its mass number is 238. Whenever alpha particle will become outside, obviously this mass number will become how much means 234. As mass is directly proportional to the what means mass number itself. So M1 V1 is equal to, I will write M2 V2. 234 V1 is equal to 4 into. So it is started with U velocity itself. Then V1 is equal to, you will get 4U by what means 234. The only thing is, if I represent with the direction itself, then I should write what means minus, minus. Negative sign indicates that the velocity of the residue nuclei will be opposite to the direction of the what means alpha nuclei. Minus 4U by 234. If you are asked, say the kinetic energy of the alpha particle is K, then what is the kinetic energy of the what means residue nuclei? Then how will you do that one? The kinetic energy of the alpha particle is given to you K. Then what is the kinetic energy of the what means residual nuclei? Alpha particle kinetic energy Ke is equal to what should I write? What is the formula for the kinetic energy? Half mv square. Or I can write what? E square by 2m. M means what here? Alpha. This value is given to you what means K. Then what would be the kinetic energy of the what means the residual nucleus? That is Ke remaining nucleus, let me call N, is equal to, again I have to write what? This is the momentum of the alpha particle, momentum of the nuclei by 2m into residual nuclei. Then how much its value is asking that one. Then what to do? Very simple. Take the two equations, divide it. Ke alpha by Ke, and that is K by kinetic energy of the nuclei The rest of the nuclei is equal nothing but these two will be gets cancelled, isn't it? When I divide it. Why? You see, law of conservation of linear momentum. Momentum of alpha particle is equal to remaining nuclei is equal to moment of alpha particle. So both will be get cancelled. Then what you get? Mass of the nuclei will become up, mass of the alpha particle will become down. Then what is the kinetic energy of the nuclei? Is equal to nothing but K into M alpha by M. We know 4K by what means 230. So that also we can find out. Next. This problem is based on how you calculate, whether you, how quickly you can calculate. That's all. The question is very simple. Assume that protons and neutrons have equal masses. Mass of the nucleon is something is given to you 1.6 into 10 to the power of minus 27 kilograms, and the radius of the nucleus also given to you, so 1.5 into 10 to the power of minus 15 a power 1 by 3 meter. The approximate ratio of the nuclear density and water density is equal to n into 10 to the power of 13. What is the value of n like that? I will tell the way how to solve this problem. First, you require to find out the what density of the nucleus with the given data. Actually, we already seen that its value is some 2.9 something 10 to the power of 17 kilogram per meter cube like that. So, however, this data is given differently, so we have to follow that one. That is mass by value. Mass of the nucleon is how much is given to you? 1.6 into 10 to the power of minus 27. Next, we have to find out the what radius. Radius value we have to find out. That is 4 by 3 pi means how much? 3.14. Radius is given 1.5 into 10 to the power of minus 15. So whole thing you have to write. You don't have any other choice. 1.5 into 10 to the power of minus 15 into a power 1 by 3. I think this I have to take what? Q. And moreover, the mass of the nuclear is given to you. How many number of the nucleons will be present? A. Let's just go on doing the what means this multiplication. A power 1 by 3 whole cube. A will be gets cancelled. 1.6 into 10 to the power of minus 27 by this will get some 1.33 into 3.14 into 1.5, 1.5. Here only your calculation skills will be just estimated. How quickly you will do that one. So 10 to the power of minus 13 power 3 means minus 39. You please solve this and you just divide this with the what means water density. What is the density of the water means? Density of the water is equal to what means 1000 kilogram per meter cube. So you take the nuclear density, take the water density and take the ratio. Previously we wrote how much means some 10 to the power of 17. This will get some multiple of 10 to the power of 17 by 10 to the power of 3 actually you will get. So that is 10 to the power of 14 into something you will get. The value, so basing 10 to the power of 13 is given. So 10 into 10 to the power of 13 maybe if you find out that ratio, that any value you will get how much means maybe around 10 or around 11 or around 12 actually. Just the calculation is given to you only. How quickly you do that one? Mass is given, mass you know, volume is you know, find out the nuclear density and take the ratio. We go to the next problem. You just take the how we are going to do the problem and the start the calculation you do later. And one more problem based on the binding energy. If M0 is the mass of the isotope of 512B, MP and Mn are the what means masses of proton and neutron, then nuclear binding energy of the isotope is equal to how much? Binding energy, simple. That is mass defect into how much means C square. If you take in AMUs into multiplied 931.5 mega electron volt. If you want to take in joules, delta M into C square, you will get in joules. So mass defect simply you write down what is the mass of the nuclei. Mass of the nuclei is nothing but what? Mass of the proton and mass of the neutrons. Calculated mass. Calculated mass means how many protons are there? 5 protons are there. 5 EMP plus how many neutrons are there? 7 Mn. This is the mass of the nucleus. MPMN given. M0 is the mass of the isotope. This is the mass defect. Now binding energy is equal to, if you multiply with the C square, you will get what? And if you write all the values in kilogram, you will get value in joules. Or if you take any AMUs and multiply with 931.5, you will get in mega electron volt. So let me tell this last problem. Shall I? The problem. Okay, let me tell this problem. It's also simple one. Atomic mass of the C612 is given to you, 12 AMU. Mass of C612 is given to you, 12 AMU. And that of C613 is given to you. Its mass also given to you, 13.0033554 AMU. The energy required to remove a neutron from the C613 is equal to how much? That is C613 should become C612 and neutron. So mass is going to be decreased. So how much difference of mass is there? Delta M is equal to. You simply subtract this one. That is equal to, you will get some 1.000335554 AMU. Then how much energy is required? Energy is equal to nothing but delta M into 931.5. You please calculate. And of course, here mass of the neutron also we have to calculate. Here that I did not come included here wrongly. I have taken wrong. Here mass of the product reactant is mass of the reactant is equal to this. how much mass is 12 plus mass of the neutron 1.00, that is we'll get 13.0086665. Now you take this difference and this difference, delta M. You take that one and find the binding energy in mega electron. This mass is different, this mass is different. Mass is going to be decrease to find out. Or removing the neutron means you require to add the what means energy. So calculate. Okay, that's all. I think if you follow the simple mathematical principles and with a little bit of remembering the what means principles, basic principles that came in the nuclear physics, I hope you can do the problems easily. And if you have any doubts, you please ask me.
సో స్టూడెంట్స్ కి ఎవరికైనా డౌట్స్ ఉంటే దయచేసి అన్మ్యూట్ చేసి క్వశ్చన్స్ అడిగితే సార్ మీ డౌట్స్ ని క్లారిఫై చేస్తారు.
Okay, don't worry, not only this time, at any time if you have any doubts, please contact our Michael sir. Sir will send to the questions to me and I will definitely clarify your doubts.